So we'll just take an example, okay, and see that how this pointer works. Okay, so I'll just create a class. Okay, so let us suppose the name of the class is test, and inside this test class I just create an instance variable a. Okay, so this is an instance data member. Okay, this is an instance data member. Okay, and in the public section I'll be just creating, okay, a function. Okay, let us suppose set, and inside this I'll be just passing a local variable, okay, that is used to assign, okay, the value to this data member. Okay, so for example, okay, if I just write, okay, cout, okay, if I just write cout address, address of the current object pointed by this pointer is, okay, so I want to check, okay, that what is the current address of the object, okay, that will be pointed by the this pointer in this particular member function when this member function is being called by that particular object. Okay, so I haven't created any object till now, but we can use it. Okay, so it will be, okay, I'm giving a space here, okay, and this will be a new line. Okay, so can you guess that what should I write in this particular space? Okay, so for example, if I create an object t, okay, so can I write n% t here? Okay, so if I write n% t, then the compiler will raise an error because now for this particular method t is not defined. Okay, this is not defined. Okay, so in order to access or in order to retrieve the address of this particular variable, okay, in order to retrieve or access the address of this particular variable, what I have to write? I have to write this. Okay, so this is a keyword that is used to retrieve the address of the current object. Okay, so the output will be n hexadecimal, okay, n hexadecimal address, okay, any address that is generated by the system, okay, and it should be in a hexadecimal form. So n hexadecimal, okay, address will be retrieved. Okay, so okay, we can't use m%, okay, object. In order to access we have to write this. Okay, so with the help of this keyword we can access or we can retrieve the address of the current object. Okay, and this is present, okay, this particular pointer or this pointer is present in this member function, that is a non-static member function. Okay, it is present and it is hidden. Okay, we can't see this, but it is hidden and it is, okay, it is pointing to the address of the current object. Okay, so it is like that. Okay, if this t is an object, so this pointer is pointing to this particular t, it is pointing to the address of t, but it is not visible to us. Okay, it is working in background, it is implicitly, okay, we can say it is implicitly passed as a hidden argument by the compiler. Okay, we can't see, but the compiler is passing this particular, this pointer as a hidden argument implicitly, and it is added to all non-static member functions that are being created in a particular class. Okay, if we have 10 non-static member functions, so for all these 10 non-static member functions, okay, this pointer will be present, okay, in a hidden mode, and when an object will be called on this particular member functions, okay, so compiler will pass this pointer as a hidden parameter implicitly, and this pointer will be invoked inside these non-static member functions. This you have to remember. Okay, this you have to remember that, okay, this pointer is passed, okay, as a hidden parameter. So you have to remember that this pointer, okay, this pointer is a hidden parameter. Okay, it is a hidden parameter implicitly, implicitly added to all the non-static member functions of a class. Okay, implicitly means by the compiler. Okay, by the compiler. Okay, so user is not aware of. Okay, so we can say it is also an example of abstraction. Okay, where the user is not interested that what, okay, this pointer is pointing and what is the current address of an object, because we are not very much concerned of this particular thing. Okay, we are very much interested that what will be the output of our program. Okay, the value that has been assigned, whether it is being printed or not, but we are not interested that what is the, okay, what is the address of that particular object and how this pointer is pointing to the address of the particular object. That is of no use to us. Okay, so this is, okay, done implicitly by the compiler, but we can also explicitly, okay, see the address with the help of this keyword. Okay, and we can also explicitly access that particular variable with the help of this. Okay, so when, okay, when you can say compiler, okay, when there is a call to a specific member function, okay, that has been called by a particular object, so the compiler, okay, creates a this pointer for that particular member function, and inside that particular member function the scope of this pointer is limited, and this pointer, okay, this pointer points to the edge, points to, okay, the particular, you can say, object, and it holds the address of an object. Okay, and at the same time the compiler will replace all the data members. Okay, all the data members are replaced by something like this. Okay, this pointer a. Okay, so if we have assigned, okay, if we have assigned like something a is equal to x, okay, then the compiler will resolve this particular statement as, okay, this pointer a is equal to x. Okay, so for the compiler this statement will be resolved like this. Okay, so internally it is being resolved by this. Okay, so resolved by the compiler. Okay, so this we have to remember. Okay, internal, internally resolved by the compiler. Okay, so I am not seeing this particular thing. Okay, I am not seeing this thing in my program, but compiler is resolving this thing like this. Okay, but explicitly we can also, okay, in our member function we can also assign the value of x to a like this. Okay, so it can be done explicitly also. Okay, but in a background compiler, okay, is doing, okay, in your program for all the member functions. If you are assigning certain data members, then all the data members of a class, okay, if I'm saying data members, so I am resembling to a class. Okay, so all the data members, okay, so this x is not a data member of a class. Okay, this is only a local variable to a function. So a is a data member of a class, so all the data members are replaced by a this keyword. Okay, this pointer a. Okay, and it can be accessed like this, like pointer to an object. So now, okay, what we have completed till now, we have just created a member function, and again, okay, I am interested in creating a display method. Okay, so I just create a method, for example, show. So in this particular method, okay, I am more interested in displaying the value of a. So I'll just write cout a, okay, and new line. Okay, so let's try and create a main function. Okay, so this is our main. So inside main, what I'll do, I'll just create, let us suppose, object t1 and object t2. So two objects have been created. Okay, so now independently for this object and independently for this object, okay, this pointer will be, okay, there in our program if we are working on some particular methods, okay, or some particular member functions. So if I just write t1 dot set and I just pass 10, okay, if I write t1 dot set and I pass 10 as a parameter, so it means now this t1 is a caller object. Okay, so this is a caller object. Okay, this is a caller object that is working on this member function set. Okay, so this set is a non-static member function that we have created. Okay, this is a non-static member function that we have created. Okay, so the control will be transferred. Okay, the control will be transferred to the calling, okay, to the collie. Okay, and the collie is here. Let us suppose the collie is, okay, I'll just write it like this. Okay, the collie is this. Okay, set is the collie, so the control will be transferred, okay, to this particular collie. And inside this, what the compiler will do, okay, compiler will replace this statement, okay, a equal to x will be replaced like this, okay, arrow operator a. Okay, so I am not writing this dot a. Okay, dot will not be there, because if I am working with pointers, okay, if there is a pointer, okay, or there is a, okay, pointer that is pointing to an object, so pointer to object mechanism is there, so we have to use this keyword, and we have to use this arrow operator. Okay, so this is a, you can say, member access operator. Okay, don't use dot. So you have to use this arrow a, okay, is equal to x. Okay, so if you use this, then also there will be no error in your program. But if you don't use this, okay, if you are not using this, then the compiler is implicitly converting this statement as, okay, the compiler is implicitly converting this statement like this statement is being converted like this. Okay, and inside this, okay, the address will be printed with the help of this keyword, so it will print the current object's address. Okay, so what is the current object now? The current object is t1 that has been called on this set. Okay, so the address of the t1 in hexadecimal will be printed. Okay, and after this, the scope of this member function is, okay, completed. Okay, so now this pointer will be finished. Okay, and again, if I just write t2 dot set 20, so again for this particular t2, okay, because I am invoking this object on this particular member function, so again a call will be generated, and again this pointer will be invoked, and this pointer will now point to the, okay, to the address of this particular t2. Okay, so now this pointer will hold the address of the current object, and now the current object is t2. Okay, so now t2 will be pointed by this pointer, and now the address of t2 will be retrieved by this keyword. Okay, so in this way this pointer works, okay, in a background, and okay, it is invisible. Okay, we can't see it is present in every non-static member function, and implicit call will be there by the compiler. Okay, and we'll just write t1 dot show and t2 dot show. If I want to see the value, okay, so here if I want to see the values of, okay, a, because a is a data member, so here you can also see, okay, there are two different values of a. Okay, a, because this data member I am more interested in. Okay, and I have only declared a single a. For this a there are two values. Okay, one is 10 and other is 20. Okay, so the compiler is assigning this value like this. Okay, so the when the call to a member function is there, okay, so this pointer is responsible, okay, for retrieving the address and for returning that particular address to that particular caller object. Okay, so that the value must be retrieved in this way. Okay, so if set function, okay, is called on t1 object and a parameter 10 has been passed, then this pointer will retrieve the address of this t1, and it returns, okay, the address, okay, to this particular t1, and this t1 contains the value 10. Okay, so we can say that this is pointing to 10 for this t1, and this is pointing to 20 for this t2. Okay, so in this way a same variable has been assigned two different values in our program with the help of two different objects. Okay, but a single member function is being available to all the objects. Okay, here you can see the member function is same. Okay, we are not creating multiple member function, but a single member function is being created, and this single member function is being worked upon by different objects, and we are retrieving the address of these, okay, different objects with the help of this pointer, and we are returning these objects, and as a result of which the values are retrieved. Okay, because values are also retrieved because the object binds the data variable in itself. Okay, so this t1 binds in itself a. okay, and A contains 10. In the same way, T2 binds in itself B, okay, sorry, A, and A contains 20, okay, and there is some address here and there is some address here, okay. So on the basis of the address, this value is being, you can say, accessed, okay, by the compiler. So this is the mechanism of this pointer. Another use of this pointer is that we have, okay, that we have discussed, okay. The second use is that it is used to differentiate between the local members and the data members of a class. So what it means, okay, so if I just write the same program here, okay, I just create a member function, okay, I'm not writing the whole program, okay, I'm just creating. So this is a private data variable that we have created, and in the public section, okay, I'm just creating a member function set, okay. So for example, inside this, if again I write A, okay, so now what I am doing, I am just doing A equal to A, okay, I am doing A equal to A. So now there is a problem that the name of the instance, this is an instance, okay, we know that this is an instance and this is a local. Okay, so now what is happening? The name of the instance variable as well as the name of the local variable, both are same. Okay, so now the compiler will be in a state of confusion that, okay, A is assigned to A, okay, A is assigned to A. So now this A will be hidden, okay, the compiler is unable to read or unable to recognize this A, okay, because we know that inside a function the priority is given to the variable that is more local, okay. So now if the name is same, then the priority will be given to this A because this is local, okay, this is local. So this local will be assigned to this local, okay, this A will be assigned to A, this A will be assigned to A, okay. And if in show function, if I just print, okay, if I just print the statement cout A, okay, so there will be no error, compiler won't generate any error, okay, it will be, okay, in a state of confusion, it will just assign A to A. It says that local has been assigned to local, okay, so the compiler will read the left hand side variable as local variable, not as an instance variable, okay, because it has been now assigned, it has been assigned inside a block, and we know that local variable, okay, in a programming, local variable is given more priority, okay, and the name of both these variables are same. So because of this, okay, A will be assigned to A. So if I try to print the value of A, then some garbage value will be printed, okay, some garbage value will be printed. Why the garbage value is being printed? Because this A is not known till now, okay, this A is being hidden by the, for the compiler, okay, this A is being hidden from the compiler, it is being hidden from the compiler, okay, and because the compiler only knows this A, compiler only knows the local variable because it is assigning local to local, okay, because the name of both the variables are same, so the priority will be given to local, and this A will be hidden, okay, the value of this A is not known to the compiler. So if I try to access this data member, now this A is the data member, so some garbage value will be printed, anything, okay, some garbage value will be printed that is of no use. So in order to remove this particular ambiguity, or in order to remove this particular confusion for the compiler, okay, this keyword has been introduced. So what we will write, in spite of writing A equal to A, we will just write this arrow A, this arrow equal to. So now when we write this arrow operator A, then the compiler will be, okay, knowing that now we are, okay, more interested in accessing the value of the data member, okay, because this pointer is for the object, it holds the address of an object, and an object contains the attribute that is the data member. So this pointer means now the local value will be assigned to the data member, okay. So inside this, if I just want to print cout A, so now the updated value will be printed, okay. So now the compiler can distinguish between the local variable and the data variable, okay. So now this is a data variable, okay. Now the compiler is differentiating with the help of this keyword, this arrow operator. So don't use dot operator, just use arrow operator because we are working with pointer to object, okay. So for an object, this pointer is there, and for an object, attribute is there, attribute is the data member of a class, and data member of a class is being known by the compiler with the help of this keyword, okay. So I hope now this is clear to you. So we'll just see the practical implementation with the help of a program, okay. Again, one thing, okay, that I want to, okay, tell you that it is a important concept. Okay, we are not, okay, we don't write this type of things in our program, but okay, you should know that if, let us suppose, in our program inside main, okay, if we are creating an object test t, okay, and we just write, okay, we just write t dot set, and we just pass 10. So the compiler, when our code is compiled, so the compiler will replace this call. Okay, the compiler won't read this call like this. Okay, so this call will be replaced by the compiler as t dot set m% t comma 10. Okay, so in spite of one parameter, compiler is passing two parameters. Okay, so this call is being resolved, okay, resolved by the compiler like this. Okay, the compiler is viewing this statement like this. Okay, so ampersand t means, okay, the reference of this object has been passed and 10 is the value that we are passing. Okay, so now in the definition part also, the compiler will replace the definition also, because in definition we have just write void is set and an empty thing. Okay, so if I am writing, okay, I'm passing the reference, okay, I means compiler. Okay, here compiler is passing. Okay, it is hidden from the user. Okay, the user is not able to see this because it works in background. Okay, there are certain things that compiler is doing implicitly that is not known to the user. So implicitly compiler will also write, okay, the syntax. Okay, it will also replace the syntax void set as, okay, the name of the class, that is test, followed by pointer, followed by constant, okay, comma, and int x. Okay, so now this is being replaced like this a equal to x. Okay, so this has been replaced by the compiler like this. Okay, so test pointer constant means you can say a constant. This pointer has been created, okay, that is used to hold the address of this reference variable. Okay, this, the compiler is solving, okay, assigning the local variable to this particular, okay, data member like this arrow operator a. Okay, so the compiler is resolving the whole function call and the whole definition like this in background, and this is, okay, this is hidden from the user. Okay, in this way this function works in background. So I hope now this is clear to you.